Here is an expert-level circle question. The radius is 37. Two parallel chords on the same side of the center have lengths 24 and 70. We need the distance between them.
Before calculating, study the picture. The longer chord lies closer to the center. The shorter chord lies farther away. Our unknown is the gap between those two parallel lines.
Pause here and try it first. I see two chord lengths and a radius, but I do not see a triangle yet.
The hidden construction is the key theorem. A radius drawn perpendicular to a chord bisects that chord. So each chord becomes the base of a right triangle.
That means I should not use 24 as a triangle leg. Half of 24 is 12, so the first half chord has length 12.
Exactly. The hypotenuse is the radius, 37. Let D1 be the perpendicular distance from the center to the shorter chord. Apply the Pythagorean theorem.
So D1 is the square root of 37 squared minus 12 squared. That is the square root of 1369 minus 144, or the square root of 1225.
The square root is 35, so the shorter chord sits 35 units from the center. That makes sense. A short chord near the edge is far from the center.
For the longer chord, half of 70 is 35. Now 35 is the triangle leg, not the distance from the center.
Let D2 be the distance from the center to that longer chord. Again, use the radius as the hypotenuse and the half chord as one leg.
That gives D2 equals 12. The longer chord is only 12 units from the center, which matches the picture. Now I have 35 and 12. Should I add them or subtract them? This is where the phrase "same side of the center" matters.
Both chords are measured outward from the center in the same direction. Their separation is therefore the absolute difference between their center distances.
35 minus 12 is 23, so the distance between the two chords is 23 units.
A common trap is adding 35 and 12 to get 47. That would be correct only if the chords were on opposite sides of the center.
Another trap is putting the full chord length into the Pythagorean theorem. The perpendicular radius bisects the chord, so the triangle always uses half the chord.
There is also a useful number pattern here. 12, 35, 37 form a Pythagorean triple. The same three numbers appear again with the legs swapped.
My three-step summary is: have each chord, use a right triangle to find each center distance, and then use the location phrase to choose subtraction or addition.
For any chord of length C in a circle of radius r, the center distance is the square root of r squared minus the square of half C. The diagram tells you how to combine two such distances.
The final answer is 23. The decisive details were perpendicular bisectors, half chords, and the phrase "same side of the center."
This lesson is linked to the new 5-year workbook as 2025, Module 1, Question 22. Try the next problem before our next visit to the observatory.